In this example, we're going to determine the composition f composed with g if f is the linear function 2x minus 1 and g is the quadratic function 3x squared plus 2x minus 1. I think of f composed with g as f of g of x. This means inside our function for f, anywhere we see x, we can actually substitute in the function g of x. So making this substitution, we'll get 2 times 3x squared plus 2x minus 1. So here we've substituted in g of x for this x here. And then our f function still has this minus 1 at the end that we have to deal with. And now we can distribute through the brackets to get 6x squared plus 4x minus 2. And simplifying just a little bit gives us 6x squared plus 4x minus 3. Next, let's reverse the order of our function, so we're calculating the composed function g composed with f. In this case, we can think of it as taking the function g, and everywhere we see x in our function g, we're going to put in the function f of x. So g is 3x squared, so we'll get 2x minus 1 squared plus 2 times 2x minus 1 minus 1. So let's go ahead and distribute through our brackets here. We're going to get 3. If we take 2x minus 1 and square it, we should get 4x squared minus 4x plus 1. And I'm going to expand through the brackets here to get 4x minus 2. And I need one more distribution here with the 3, so we should get 12x squared minus 12x plus 3. And then we're going to need to collect our like terms. So it looks like we have only one x squared term, so we're going to be left with 12x squared. We have to collect our x's together, so we have negative 12 plus 4, that's negative 8 x's. And then we have a plus 3 and a minus 3, that's going to give us 0. So here is g composed with f, 12x squared minus 8x. So one thing to notice is that the order of composition does matter. G composed with f that we calculated here is different from f composed with g that we calculated earlier.